So, welcome. So, today we'll be talking about accelerating your next innovation with Keysight Quantum Solutions. So, my name is José Pino. I'm the principal software architect for Keysight Quantum Solutions. I've got over 2 decades of experience here in Keysight Technologies focusing on software. Before joining the Quantum Solutions team, I was part of ESOF EDA, where I was a principal engineer on the system level design tools and on Pathway FPGA. We have a large team here in Keysight Technologies focused on quantum solutions, shown here in the picture. And I'd like to introduce you to the panelists that we have today. Eric, can you please introduce yourself?
Good morning. My name is Eric Holland. I'm a quantum R&D physicist in the Quantum Engineering Solutions Group. Before Keysight, I was the deputy head of quantum technologies at Fermilab and the chief quantum hardware and application architect at Lawrence Livermore National Lab.
Diego, could you introduce yourself, please?
Hello, everyone. My name is Diego Risté. My background is in experimental quantum computing as well. I did my PhD in Delft University of Technology, working on measurement and feedback with superconducting circuits. And more recently, I worked at Raytheon BBN Technologies here in Massachusetts, also demonstrating techniques for error correction and developing novel control systems for superconducting qubits before joining Keysight.
And now Philip.
Hi, my name is Philip Krantz. I'm a business developer in the Quantum Engineering Solutions team at Keysight. And I did my PhD at Chalmers, working on superconducting qubits. I then did a postdoc at MIT, also working on superconducting qubits. And recently, just before I joined Keysight, I was the coordinator of the Wallenberg Center for Quantum Technology in Sweden.
Oh, thank you. So now that we've all introduced ourselves, I want to give a little bit of Keysight history. So Keysight's the original T&M part of Hewlett-Packard, and it was formed as a spinoff of Agilent Technologies in 2014. And Agilent was a spinoff of Hewlett-Packard in 1999. Hewlett-Packard was founded in 1939 in the garage of Bill and Dave, shown here. Their first product that they designed and built together in that garage was a 200A audio oscillator. This audio oscillator was purchased by Walt Disney to create the breakthrough surround sound of the movie Fantasia. This garage has such historic significance that tourists visit it today, and it has a placard indicating that it is the birthplace of Silicon Valley. So since 2015, we've been growing our software businesses by many different acquisitions. And these acquisitions total over $2 billion, and they span many different industries. These industries all in with the technologies interplay, and we are able to leverage technologies that help reinforce each other, including quantum. Since 2016, we've been doing acquisitions in the area of quantum. Our first acquisition was Signadyne, a startup out of Barcelona, Spain. Signadyne was focused on trapped ions, and in their experiments, they found that they did not have the proper quantum control software and hardware that they needed to do their experiments, so they created that. This quantum control software and hardware are some of the underpinnings of our products today. In 2018, we joined the Boulder Cryogenic Quantum Testbed, a research area that was focused on superconducting qubits and the dielectrics needed for those. We've provided high precision test equipment for that, and we also are collaborating in research, and we've published with Google and NIST. In 2019, we purchased Labra Quantum, and Labra Quantum is a spinoff from MIT, and it was formed to create software to help streamline quantum experiments. Earlier this year, we launched a brand new Keysight site in Cambridge, Massachusetts, totally focused on quantum, and it's our Quantum Software Center. Just a few months ago, we were awarded as one of the principals of QNext, a big project funded by the Department of Energy in the area of spin qubits, and this is bringing together industry, universities, and national labs to focus on quantum research together. And next year, we'll be working with MIT to help provide them the quantum control software and hardware needed for their 64-qubit quantum test bed. Now, a bit more about our Quantum Software Center. We have been actively hiring at the Quantum Software Center over the last year, and we're quickly growing that. All of the panelists today and I all report into this Quantum Software Center. I want to highlight an additional person at this software center, Simon Gustafsson. He is the former CEO and founder of Labber, and also a MIT principal scientist. And with that, what I would like to do is turn it back to the panel and begin the questions. So, Eric, what are the greatest challenges you see in quantum research?
Thank you for the question, Jose. So my prior experience in leading quantum hardware development efforts in the Department of Energy has given me a unique perspective on the trajectory of quantum technology. First is that the high-level application use cases of quantum, such as chemistry and optimization, coupled with the rapid progress we've seen in quantum over the last 5 years, has resulted in substantial and sustained long-term investments, both globally as well as here in the US. These investments have solidified quantum as an industry, and as such, it will be a sustained marathon rather than a sprint. The second is that quantum is a multidisciplinary and competitive landscape, with time to break through being at a premium. Many outsiders assume that quantum is a mature industry segment with slick, streamlined solutions, such that high-level applications are easily executed on quantum processors. However, the classical software, firmware, and hardware systems integration is far from trivial. Diego, based on your experiences at Raytheon BBN, could you speak more to some of the challenges you faced?
Yeah, sure. To add on what you said, Eric, in my experience as a researcher prior to Keysight, with my team working with superconducting circuits, we often have to work on parts of the whole system of the quantum computing stack. So one thing that was missing was the ability to rely on parts that were designed and tested with quantum applications in mind. And so often we had to sort of rely on buying off-the-shelf hardware and then sort of modifying it to meet our needs. Obviously, that does not scale very well building larger systems and has limited capabilities in doing so. So now that the quantum ecosystem has expanded dramatically, there are now professional solutions that are become available, which allow researchers to focus more on their research goals rather than on the whole system.
Great, thank you. So, Diego, what are the industrial trends of the quantum software ecosystem?
Yeah, thanks, Jose. As I mentioned before, as the quantum ecosystem grows, we start seeing more specialized companies and research labs that tackle different areas of this quantum computing challenge. So here we divide this ecosystem in 5 broad categories, going from the highest conceptual level of designing an application, compiling that into an algorithm and the quantum gates, down to synthesizing those gates into physical waveforms, all the way to routing to the quantum processor itself. All of these, each of these areas require dedicated effort and specialized skills. And of course, integrating any of these components, hardware or software, with the rest of the vertical stack is a challenge, and is crucial for the development of this technology and on building systems. And there is now a growing number of offerings in each of these categories. And so the challenge becomes picking a sort of vertical slice that allow you to build a system in a way that these components are compatible with each other. So, Philip, where do you see the role of Keysight in this landscape?
Within this quantum ecosystem that Diego told us about here, Keysight plays an active role in the quantum firmware and software. That you can see marked in red here. We have two different layers of this, bridging the gap between the physical qubit layer and these higher level software solutions. First, we have Labber Quantum, which is the higher level control software to enable researchers and engineers to make quick and easy measurements and experiments by sending signals to the physical qubits. But then we also have PathWave, and you might recognize PathWave from many different applications from Keysight. And in this context, we talk about PathWave FPGA and PathWave Testing Executive that allow our customers to directly customize the use of the FPGAs in the instruments. And combined, these two layers allow researchers and engineers to really focus their time on doing research and developing the qubit plane instead of developing the control software. And it enables them to enter into the stack in different entry points depending on their needs.
Great, thank you. So, next question, I'd like to direct it to you, Eric. How do you optimize the performance and time to solution for quantum systems?
Okay. Yeah, as we've heard so far, the quantum ecosystem will continue to grow organically, both vertically and horizontally, as new use case drivers emerge and evolve. As such, well-defined in software architects they must be flexible so they can integrate together easily and enable quick time to solution for researchers. At Keysight, we've been thinking about our solutions in terms of puzzle pieces. So starting at the top, we have Ware Quantum, which connects at the software, firmware, and hardware level to organize and execute quantum algorithms and experiments. Ware Quantum fits into the classical firmware components, such as Pathwave Test Sync Executive for timing and synchronization, as well as Pathwave FPGA for quantum IP libraries. These two are closely tied to the Keysight portfolio of quantum control solutions. We give researchers the hooks for all of these solutions to fit together seamlessly, as well as empower our users to develop their own custom puzzle pieces. So Philip, do you have any way of thinking about this puzzle piece paradigm to help improve the development cycle between academia and industry?
Yes, to minimize the time to solution, it's very important with a strong synergy between academic research and industry. And quantum computing has become more and more interdisciplinary, as well as transformed into more engineering intense. Therefore, it's important that industry steps in and provides academic researchers with the proper tools so that they have the time to advance research further. And what you can see here on this slide, you have this synergy between academic and industry shown with arrows, where the academic research labs are feeding knowledge into the industrial efforts. And then the industry is in turn feeding information and tools back into the physical qubits representing researchers. So it's very important to keep this synergy going so that the academy can do what they are good at and industry can do what they are good at.
Great. Thank you. So the next question I'm going to direct again to you, Philip. How does Keysight tackle the hardware and software scaling challenges?
So to proper support high fidelity quantum algorithms, there's many requirements on the control hardware and software. At Keysight, we provide a solution based on this PXI modules that you can see schematically drawn on this slide, where we have the PXI backplane that provides tight channel-to-channel synchronization between the modules. And you can see that the Ware Quantum and Pathwave is integrated into controlling these modules. Also, you can see in the schematic that some of the modules are being used to drive the qubits, the ones in red, and then some are used to read out the states from the qubits, the ones in blue, and as well as processing the data. Diego, can you add something on this slide?
Yeah, sure. One thing I want to emphasize about this platform is that this synchronization technology that allows us to synchronize multiple modules and also different chassis with each other also allows for the fast data sharing, like classical data that comes from measurement results, in order to perform closed loop experiments such as those required for Q2B reset or other error correction or error mitigation protocols as well. And one more thing to note here is that all these different experiments can be configured in software. So there is no actual need to either change the physical connections or program specific purpose FPGA images just for single experiments, as it's all it's programmable in software indeed. So that's a powerful feature of this architecture.
Great, thank you. So we're getting close to the end of the session. And what I'd like to do is allow all the panelists to give some parting remarks on this area. So I want to start with you, Eric.
Sure. So I would like to everyone to think back to the puzzle piece analogy and consider where and how do the puzzle pieces they're developing fit in with the greater quantum ecosystem. If we get more people thinking about the ecosystem holistically, as well as how they fit into it, this will increase not only the desire, but also the need for standardized vertical and horizontal interconnects. Doing so will break down silos, increase multidisciplinary collaboration, and spur innovation in the coming decade. 2020 has been a challenging year, but things have never looked brighter in quantum. Thanks.
Great. And now you, Diego.
Yeah, as a final comment, as a researcher myself, I was excited to join Keysight this year for their new strong initiative in quantum computing, and especially with this software center that we mentioned, established in Cambridge this year and still growing. We hope we can contribute in developing new solutions that will benefit you computing scientists, quantum computing scientists, and engineers around the world to advance your research. So we hope to engage you actively in this process. So please, if you're interested, don't hesitate to contact us.
Great. And you, Philip?
Yes, I want to again emphasize the importance of synergy between academia and industry, and also between industry and industry. So for those of you that have interest in collaborating with Keysight in some way, or that are interested in learning more about solutions that we have, I want to encourage you to reach out to us.
Great. Thank you. And so my parting thoughts are, in the Quantum Software Center, we're embracing agile software development techniques. And what we're trying to do here is engage with our customers in a tight collaborative nature to develop our software. We develop our software in 2-week sprint increments and bring in our customers to review our software every 2 weeks. At the end of those 2 weeks, we also make those that new software available in the form of alphas and betas so that our customers can try it out in their labs and give us more feedback. And that way, we are able to go in and make changes in the software on a continual basis to best meet customer needs. And what I'd like to do is use this to help foster customer engagement. Now, if you like what you've heard today and would like to partner with Keysight strategically in the area of quantum, I encourage you to reach out to our business development team. Our business development team is shown here. So in the Americas, we have Sonali Sarpatar, and so please contact her, and her email is shown. Focusing on Labber is Philip Krantz, one of our panelists here today. And in Europe, we have José Luis Preciado. So please reach out to him. You can also find more information about all of our products at www.keysight.com, find Quantum. And also, please visit our virtual booth later today, and you can talk to some of us there. Thank you very much.